This is lecture 2 in Map of the Modern World, which deals with the atmosphere. The atmosphere, or what we commonly call the air, is a blanket of gas that surrounds the Earth and is held to the surface of the Earth by gravity. The air, or atmosphere, is composed primarily of nitrogen and oxygen, and also a very small portion of what are called trace gases: carbon dioxide, water vapor, methane, and various nitrogen oxides that we'll talk about later in the course. We'll examine 3 features of the atmosphere: its temperature, its movement, or what we commonly call wind, and its role in transporting water, or what we call precipitation. As we move through these 3 features, we'll look at 5 simple rules that govern the behavior of the atmosphere. First, in terms of temperature, we'll note that the sun heats the Earth unevenly. Rule 2, that the sun heats the Earth and the Earth heats the air. That is, the sun does not heat the atmosphere directly, but first heats the Earth, and the Earth is the source of energy that heats the air. Thirdly, that in looking at the movement or wind, we will note that the weight of air is different. Warm air is lighter than cold air. And we will also notice that the rotation or spin of the Earth moves the air by what we call the Coriolis force. And finally, Rule 5, when we look at precipitation or rainfall, we'll notice that warm air absorbs more moisture than cold air. The application of these 5 rules explain the temperature, movement, and precipitation in the Earth's atmosphere. So let's first look at temperature. Rule number 1 is that the sun heats the Earth unevenly. This slide shows solar radiation, the electromagnetic waves that carry energy from the sun to the Earth. Some of these rays hit the Earth perpendicularly, as near the equator, and some hit at a sharper angle, as near the poles. This slide explains how these different angles affect the heating of the Earth. If you'll notice here, the solar radiation in each of these columns is essentially the same. But column A hits the Earth perpendicularly near the equator at 0 degrees latitude. In this way, this column of radiation is concentrated in the smallest area, so it receives the greatest energy per unit of area and therefore heats the Earth the most. Columns B and C, which are located progressively at higher latitudes, nearer the poles, spread out the same amount of radiation over a larger area, and therefore each unit of area receives less solar energy and is therefore heated less. In other words, the temperature of the Earth varies with latitude. At low latitudes near the equator, the temperature is high. At higher latitudes near the poles, the temperature is low. In other words, it's hot in the tropics and cold at the poles. Of course, you already knew this, but keep it in mind because it is an important principle that will explain much of the subsequent motion of the atmosphere. The second rule that we'll look at in understanding the temperature of the atmosphere is the rebound principle. That is to say, the sun, or solar radiation, heats the Earth, and the Earth heats the air. This is obvious to anyone who's ever looked at a mountain, because at the top of the mountain, snow collects because it is cold near the top of the mountain, much colder than it is in the valley. Now, ironically, the top of the mountain is closer to the sun, but it is further from the Earth, and therefore it is colder, because the Earth is the source of the energy that heats the atmosphere, not the sun. Or consider this airplane flying at 40,000 feet altitude. Outside the airplane, it is extremely cold. In fact, ice can form on the wings of the airplane. The airplane, of course, is nearer to the sun than it was on the runway, but it is colder because it is further from the Earth. In other words, the sun heats the Earth and the Earth heats the air. These two principles, that the sun heats the Earth unevenly, or in other words, latitude matters, the closer to the equator, the greater the heat. And secondly, that the Earth is the source of heat in the air. In other words, altitude matters. The higher the altitude, the colder the temperature. These two simple rules explain the temperature of the air, and as we'll see in the next part of this lecture, also explain the motion of the air.